the PPT screen visible?
Yes, ma'am.
Yeah. So welcome everyone. We will have the first introduction class to fluid mechanics, and your subject code is 18CV33. So, mission of the department. This has already been gone through once. The program educational objectives and the program specific outcomes of the Department of Civil Engineering. So, fluid mechanics, your subject code is 18CV33. We had briefly looked at the syllabus yesterday. So in the first module, you will be studying about fluid properties. You will be studying about pressure inside a droplet, a soap bubble, or a liquid jet. You will be having capillarity and problems based on that. You will be studying about pressure, Pascal's law, and the variation of pressure with depth, how pressure can be measured with various devices like manometers or electronic pressure measuring gauges. Since we have looked at the syllabus in brief, we will immediately go to the first topic. So here we are talking about fluid, or what is the definition of a fluid? So a fluid is a substance which deforms continuously and under the action of shearing or shearing forces, however small they may be. So even for a small shearing force, there will be some deformation acting on the fluid. And when you say shear, the best example of shearing is like when you tear a paper, you pull the paper in two different directions, the surface that gets torn, that is having the action of shearing on the surface. So conversely, it follows that if a liquid is at rest, there will be no shearing forces acting, and therefore all forces in the fluid must be perpendicular to the planes upon which they act. So that is the definition given for a fluid. Now, this is just for understanding's sake. What is the basic difference between solids and fluids? The difference in behavior of solids and fluids under applied forces. Okay, when you differentiate them, you are differentiating them based on the influence of forces on them. First one is, for a solid, the strain is a function of the applied stress, providing that the elastic limit is not exceeded. For a fluid, the rate of strain is proportional to the applied stress. So that is the first difference between a solid and fluid when force is being applied. The second one, the strain in a solid. Strain, you know what it means is the expansion. In a solid is independent of the time over which the force is applied, and if the elastic limit is not exceeded, the deformation disappears when the force is removed. All this you have studied as part of your physics also. A fluid continues to flow as long as the force is applied and will not recover to its original form when the force is removed. So that is again another basic difference. So when the force is removed in the case of a solid, the deformation disappears. But even when you remove the force in the case of a fluid, the deformation remains as is. So that is the first, the first and second difference between the solid and the fluid. Now, although liquids and gases both share the common characteristics of fluids, they have distinct characters of their own. So previously what we saw was about a solid and a fluid. And you know that fluids can be either liquids or gases. But even then, they have certain characteristics which are specific to the liquids or gases. A liquid is difficult to compress and for many purposes may be regarded as incompressible. Okay. So to compress a liquid, it is little difficult. A given mass of liquid occupies a fixed volume irrespective of the size or shape of its container, and a free surface is formed if the volume of the container is greater than the liquid. So suppose I take a large beaker, and if I fill, say, water in that beaker, then water will be there up to the level in the beaker where I have taken it, and there will be some free space which is the interface between the liquid and air. Okay, if you are having a large volume. So if you are taking a volume of liquid smaller than the container, then there will be a free surface formed at the top. Whereas all of us have seen gas cylinders, okay, compressed, our even LPG cylinders, and so we know that a gas is much easier to compress. Changes of volume with pressure is large. So that means the more pressure you apply, the volume will compress more. And cannot normally be neglected and are related to changes of temperature. So pressure and temperature again, okay, are related. And because of that, there will be an influence of temperature on the effect of volume based on the pressure that you are applying. A given mass of gas has no fixed volume and will expand continuously unless restrained by a vessel or a shape to hold that. It will completely fill any vessel in which it is placed, and therefore there will not be any free surface that is formed. So in the liquid, I told you, if you take a large beaker, or even if it is a closed container for that matter, if I am taking a liquid to a certain level in the container, then the space above that will not have any liquid. It is free. Whereas if I take gas and if I'm holding it within a closed space, in the same container as that we have hold the liquid, but there will not be any free space available because the gas will take up all the space within the container. That is the difference. You can see some figures that are showing how the dispersal of molecules in case of solids, liquids or gases are. Now, yesterday I told you, you have a topic we have what is called as system of units. Okay, and this is very much important for you. Most of you will remember studying this already, but these values we need to keep in mind. I have written it separately for the SI system, CGS system, etc. And all these are very familiar for you because you have studied this earlier. Okay, mass, length, time, temperature, Kelvin, mole, force, Newton, pressure, we use Pascal, but 1 Pascal is equivalent to 1 Newton per meter square. Work, if we are talking about, we talk it in terms of joules. So the word joule is already familiar to you, or joule as somebody may pronounce. Then power is 1 joule per second, which is given in terms of watts. Now you have dyne, which is the unit for force, and these are the CGS units which are very important for you. Now comes the important topic that we need to start with, which are the properties of fluids. So when we talk about property, First, we need to talk about density. And last class, during the introduction, I was trying to tell you how important knowing the density of a substance is. Why you need to find out various other properties or linked properties with respect to that particular substance. So here the definition of density, which we call as mass density, rho is the expression that we use to represent it, is given as mass by volume, and the unit is kg per meter cube. So with the increase in temperature, volume of fluid increases. So volume is inversely proportional to the temperature. So directly proportional to the temperature. So with the increase in temperature, the volume of fluid increases, and hence the mass density decreases, because you know it is mass by volume, and when the volume increases, the value of density will decrease in case of fluids. And as the pressure increases, volume decreases. So this is what I was telling you. The property of density is also influenced by other factors. Here we are showing the influence of temperature and pressure. So what happens? When temperature increases, volume increases. When volume increases, the density decreases. Whereas when pressure increases, volume decreases, and because volume is in the denominator, density will increase. So this is the property for mass density or density of a substance, which is given by the unit kg per meter cube. The next is specific weight or weight density. We use the symbol gamma for this. The weight density or specific weight is weight per unit volume. So if density is mass per unit volume, then specific weight is weight per unit volume, which is Newton per meter cube unit. So if you have the mass, you multiply it by 9.8, you will get the weight of that, and with respect to that, you have to write the unit. So you have to be very careful as to which property you are trying to find out, and the units has to be exactly written with respect to that property. This is something you need to be very, very careful about in the future classes where you are doing the numericals and things like that. Now here, let us look. With increase in temperature, volume increases and specific weight will decrease. With increase in pressure, volume will decrease and specific weight will increase. Okay, one more relationship which for you to understand, and I want this to be noted down by you. Okay, so specific weight is weight by volume. Weight is nothing but mass into G, okay, divided by volume. So if you see mass by volume, this is nothing but your mass density, which I told you is rho. So gamma is equal to rho into G. Our specific weight is mass density into G, or simple density into G. Next is specific gravity. So what is specific gravity? You can take it as specific weight or mass density of any substance divided by mass density of a standard fluid. But what you people should easily remember is this standard fluid is taken as water at 4 degrees Celsius, and the density of water is taken as 1000 kg per meter cube. Therefore, if you want to find the specific gravity of a substance, you need to know the density of that substance, because the density of water is already known to you, or vice versa. Knowing the specific gravity, you will be able to find out the specific weight or density of that particular substance. Coming to specific volume, it is the volume per unit mass. So the direct reverse of density or mass density. It is volume per mass. So the unit also becomes directly reversed, meter cube per kg. But look at the influence of temperature and pressure in this case. As the temperature increases, volume increases. So because volume is on the numerator here, specific volume will also increase. As the pressure increases, the volume decreases and specific volume will decrease. So these are. Now coming to the property of viscosity. Viscosity is the property by virtue of which a fluid offers resistance against flow or deformation. In other words, it is the reluctance of the fluid to flow. As an example, I will tell you, comparing two substances and their viscosities. You have a plain, say, laminar sheet, or let us say a plywood sheet, a very smooth plywood sheet, and on that you are pouring from the same point, you are pouring water and oil. Okay, you will see that water is moving much more smoothly and faster on the surface, whereas the movement of oil will be slightly slower. That the reason for that is the viscosity of oil, okay, which will have certain resistance to flow. Viscous force is that force of resistance offered by a layer of fluid for the motion of another layer over it. So one layer of fluid over the other, there is a sort of resistance to flow, and because of which the movement of the fluid over, say, inside a pipeline or inside a channel, everything becomes affected by that. And that is the term viscosity. Now, in case of liquids, viscosity is due to cohesive forces. When we say cohesive forces, these are the forces which are keeping the molecules of the liquid close together or keeping them all grouped together. In case of liquids, viscosity is due to cohesive forces between the molecules of adjacent layers of liquid. But in the case of gases, it is molecular activity, the movement of molecules between the adjacent layers, which is going to cause the viscosity. So both are fluids, liquids and gases. But the way in which viscosity is caused in any of them depends on the cohesive forces between the molecules in the case of a liquid and the movement or activity of the molecules in the case of gases. Now, we have an expression which is derived and told as the Newton's law of viscosity. It is explained using two plates. From the figure, you can see that at the bottom you have a fixed plate, and on the top you have a movable plate which has got a certain contact area with the fluid column, which is getting compressed in between these two layers. So you can see there are many layers of fluid, and that fluid column is getting fixed between the plate at the bottom, which we refer to as the fixed plate, and the plate which is on top, which is moving. You can see the direction of arrow, that is the direction of movement of the plate. And the perpendicular distance between these two plates is given by the distance y. Now, let us consider a fluid between the fixed plate and the movable plate at a distance y apart. A is the contact area or the wetted area of the movable plate, and F is the force required to move the plate with a velocity u. So you know that according to Newton's law, shear stress is proportional to shear strain. So F is directly proportional to the contact area. F is indirectly proportional to the distance between the two plates, and F is directly proportional to the velocity. So F is directly proportional to area into velocity divided by y. Now, removing the constant, the proportionality, you are introducing a new constant or coefficient, which is called as the constant of proportionality, or we call it as viscosity, dynamic viscosity. So viscosity is basically the term that is used to give the thickness of the fluid. So here the constant of proportionality is called as dynamic viscosity or coefficient of viscosity. Simply viscosity of the fluid is also fine. Therefore, your equation becomes F is equal to mu. Mu is the coefficient of viscosity, A into U divided by Y. Now, in that particular expression, you can rewrite the equation by bringing the area of contact below F. So the equation can be rewritten as F by A is equal to mu into U by Y. What is force by area? Force by area is nothing but stress, and in this case it is shear stress, because it is always shear force that acts on the fluid. So you have shear stress tau. That symbol written like that is referred to as tau. Tau is equal to mu into U by Y, and tau is a force required per unit area called shear stress, and the above equation is called as Newton's law of viscosity. Okay, now we need to do some simple problems regarding. First we will start with our specific weight, specific gravity, specific volume, etc. I'm going to dictate the questions. You need to write down the questions and then we will solve the questions. Okay. So I'm stopping the sharing of this, and I will directly first dictate the question, and then I will solve your problem on the notepad. You need to copy down the question first. So please note down this question. Calculate this.
1 minute. Yeah, ma'am.
Calculate the specific weight density, and specific gravity of 1 liter of fluid, which weighs 7 Newton. So that is the question.
Ma'am, which weighs?
Which weighs 7 Newton. Okay, so here first you need to have the volume. Which is given in the question as 1 liter. So if we convert this 1 liter to meter cube, this is a conversion which we should remember. It is 1 by 1000 meter cube. So you have to remember this conversion. The next is what is given is the weight. The weight is given as 7 Newton. Now, we have been asked to calculate the specific weight, which is given by definition as weight divided by volume. So please do the calculation, and what will the answer be?
7,000.
Okay, so that is 7 divided by 1 by 1000. Okay, and specific weight is always in Newton. So you will have 7,000 Newton per meter cube as your answer. Okay, so that is the first part of the calculation. Second, we needed to calculate what is called as mass density or density. Density is given as mass by volume. We have been given the weight of the material. So first we need to find the mass of the material, or if you are having specific weight, we can find it as, because you know that specific weight is rho into g. So specific weight divided by g, you can find out that. So I'm writing both the expressions here. Either you can do it as mass by volume, or you can find density as specific weight by g. Since you have already calculated specific weight at the top, it will be 7,000 divided by 9.8. So
714.
okay, 714 or 713.5, whatever comes. 713.5 that I've written here, so I will write the same, but the unit is going to be kg per meter cube. I hope it is clear to everyone. Then we have the last component, the specific gravity, which is equal to density of fluid divided by density of water. So density of the fluid is 713.5 in this case. Density of water is 1000. Both the units I have made it in kg per meter cube. Okay, if you are using specific weight, then your unit will be in Newton per meter cube. Then you need to do 1000 into 9.8 for the specific weight of water. So your answer here is going to be 0.7135, no units. So even after repeated classes, sometimes students make the mistake of putting units for specific gravity. So as a recap of what we talked about yesterday, I would just remind you of certain values that you can keep in mind so that you do not make mistakes. First is density is mass, so your unit is in kg per meter cube. Specific weight, when that weight term is itself coming into picture, you should think about newtons only, so that you have the unit in Newton per meter cube. And when we say specific gravity, always study it as the definition of a ratio. When you say a ratio does not have any unit. Hence, specific gravity will not have any unit. Whereas, when we talk about density of water, the value that you should remember, yesterday also some people confused, 1. Density is 1000 kg per meter cube, but the specific gravity of water is 1. So if you are given the density of a substance, you can find out the specific gravity because you know the density of water. Similarly, if the density of a substance, if the specific gravity of a substance is given, you can find out its density using the same relationship by simply multiplying it with 1000, which is the density of water. So these are some things that you should remember. Okay, so this was the first problem. I'm going to dictate a second problem. Kindly take down the problem. Calculate the density, specific weight, and weight of density, specific weight, and weight of 1 liter of petrol. 1 liter of petrol of specific gravity equals 0.7. Okay. So in this case, you have been given the volume equal to 1 liter. Okay, so 1 liter is again 1 by 1000 meter cube, or I will write it as 0.001 meter cube. The specific gravity is given to you and it is given as 0.7, no units. They have asked you to find out density. Density of the substance. So I'm just writing the relationship here. S is equal to density of substance or fluid, I'm writing, or here oil, you can write it as oil, by density of water. So that means the density of the substance should be equal to S into density of water. So S is given as 0.7, density of water is 1000 in kg per meter cube. So my answer that I get for density of the oil, what is this, petrol, will be 700 kg per meter cube. So that is the first component. Second component that they have asked is specific weight. Which is equal to rho or density into G. So the answer of specific weight is going to be 700 into 9.8. the answer that you get will be in Newton per meter cube. Specific weight, what is the answer that you will be getting?
Six eight six zero.
So I hope both these two components are done. Then the last one that we needed to calculate was weight. Weight of 1 liter of petrol. So weight, I need to calculate the weight. Okay, so for this, first I will write the expression. Specific weight is nothing but weight by volume. So I need to calculate the weight. Okay, so specific weight I calculated in the earlier step, that is 6867 Newton per meter cube. Okay, is equal to weight divided by volume of petrol was given, 1 liter of petrol, which when I write it in meter cube, it is 0.001. So volume, when I'm writing it in meter cube, it is going to be 0.001. So here, the most important thing that you need to keep in mind is the unit that you are using in your calculation. Number of times you will do the calculations correctly, but the units may differ. So while doing the numerical, when the data is given to you, first convert all the data in the same units so that you do not make a mistake while doing the final calculations. So here now I will get weight as 6867 into 0.001, and my answer is going to be 6.867. This will be in Newton because it is weight. So I think all the conversions of the units are all familiar to you. So I'm going to give you one simple problem with which we will wind this first numerical portion, and we will be continuing with viscosity, and there are number of problems to be done on viscosity. So just one simple question. Please write down the question, do it and tell me the answer. The specific gravity of Mercury is 13.6. What is its density? Adarsh, I want you to give me the answer.
Okay.
13,600.
When you tell that without a unit, it is meaningless. Every time you talk about density or specific weight, please talk about with unit only. So the final answer is going to be 13,600 kg per meter cube. So quick recap of what we understood today. What is a fluid? Okay. A fluid can be a liquid or a gas. What is the basic difference between a liquid and gas in terms of compressibility and uh, properties of uh, say fluids and solids, and how they vary. Then we talked about specific properties of fluids, which are density, specific weight, specific gravity, and specific volume. The relationships between them and their units have to be understood well.